Physics Lecture 4, Thermodynamics. For this lecture, we're going to go into the three laws of thermodynamics. However, there is something called a zeroth law, which we must discuss first before going into the three laws proper. The zeroth law of thermodynamics is simply a statement of the transitive property. It states that if one object is in thermal equilibrium with a second, and the second object is in thermal equilibrium with a third, then the first and third must also be in thermal equilibrium. At the bottom, there's a more simple explanation here. If A equals B and B equals C, then A equals C, hence a transitive property. Where this does apply, though, is when we talk about temperature. Temperature is the average kinetic energy of the particles that make up a substance, and the difference in this temperature determines the flow itself, hence high temperature to low temperature. Heat, on the contrary, is the transfer of thermal energy from a hotter object to a colder one. Note, this is thermal energy, so keep heat and temperature distinct. They are not talking about the same thing. When objects have no net heat flow, they are stated to be in thermal equilibrium. Units for temperature include Kelvin, Celsius, and Fahrenheit. For almost every equation that you will use on your MCAT, you will have to do it in kelvins, so make sure you understand how the conversion factors work. Generally speaking, the equation for conversions of Fahrenheit will be given to you. However, I strongly encourage you still memorize the two. Thermal expansion. Properties of matter do change as a function of temperature. This can include everything from length, volume, and solubility. But there are other properties that can change because of temperature. The two that we'll discuss, and the two that you'll probably be tested on for the MCAT, are thermal and volumetric expansion. If you notice, they have the same equation, but slightly different. Simply put, it states that the change in the length or the volume is equivalent to the property of the compound, which is noted by alpha or beta, the length or volume, times the change in temperature. It's the exact same for both, so if you have one memorized, just know that you can use it for both expansions. This phenomenon explains why railroads bend and warp, which is noted in the picture below. Because of the expansion and the changes in the lengths due to the heat of the sun, railroads eventually will bend and change. When talking about the zeroth law, we need to talk about systems as well. A system, quite simply, is a portion of the universe that is of interest. Note, it can be any size. The surroundings are basically everything else. There are three types of systems. The first is an isolated system. These systems are not capable of exchanging matter or energy with their surroundings. A closed system is capable of exchanging energy but not matter. An open one can exchange both matter and energy. Keep in mind that an isolated system technically doesn't truly exist. No matter how hard we try, there is always some form of exchange occurring. A state function is a function that is independent of the path taken to get to an equilibrium state. They are a function of only the current equilibrium state of a system. These include pretty much everything except for work and heat, which classify as process functions, which do describe the path taken from one step to another. Keep in mind which is which. It's generally easier just to remember which two are process functions and denote the rest as state functions. Now that we've discussed the zeroth law, we can finally talk about the laws proper, starting with the first. It's commonly referred to as the law of conservation, and it states that energy can be neither created nor destroyed. Since energy also equates to matter, this law of conservation also applies to matter. Simply put, you have to account for everything. Energy and matter don't just disappear or appear randomly. There has to be some path or process taken. The equation for the first law of thermodynamics is listed below, and a chart below lists the sign conventions for each one. Thermodynamic processes such as isothermal, adiabatic, isobaric, and isovolumetric will be tested on the MCAT. The expression of the first law has special forms for 3 of them, except for isobaric. Also remember that isovolumetric may sometimes be referred to as isochoric. There are 3 means of heat transfer, so let's go into them. Conduction involves the direct transfer from molecule to molecule through a collision. There has to be physical contact between the objects. If there is no physical contact, you can rule this one out. Convection is a transfer of heat by the motion of fluids over a material. Note that it states fluids, so solids can't do this. It's only liquids and gases. A lot of students get caught up by the fact that gases can do convection. Remember, gases have a flow in themselves, so they can transfer heat in this fashion. A common example would be wind. When wind hits your face, it's taking heat from your face if it's colder and pulling it away. You can say that the wind is causing convection to your face. Radiation is the last of the 3. It involves the transfer of energy by electromagnetic waves. This transfer occurs through a vacuum, making it unique from the 3. Remember this. This distinction may be tested. Hands down, the most common way that thermodynamics is tested on the MCAT is through specific heat and the heat of transformation. Specific heat is defined as the amount of heat required to raise 1 gram of the substance by 1 degree Celsius. The equation is listed below. Q equals mc delta T. It's generally easier to remember this equation as Q equals MCAT. The heat of transformation quantifies the energy of a phase change. This occurs at the melting point and boiling point, and it's listed by Q equals mL. When you think of these concepts, you need to understand that a substance will undergo changes, and that change is going to require some input. That's where the heat of transformation occurs. Think of it this way. If you start from one phase and you're putting energy into that phase, it's going and going and going until it eventually reaches a phase change, either a melting point or a boiling point. Think of this as a hill that the compound has to travel. So when you reach this barrier, you need a certain amount of energy before you can get to the next phase. This is what the heat of transformation is counting for. When you're doing a calculation that has a phase change, make sure you include the fact that you need a specific heat up to the phase change. That's one value. Then you have to include the value for the heat of transformation to the next phase. You must use both of these to do the calculation. If you only use specific heat, you will likely find an answer that looks nice on the test but is wrong. The second law of thermodynamics states that objects in thermal contact and not in thermal equilibrium will exchange heat so that the object with a higher temperature gives off heat to the lower until they have reached a state of equilibrium. To paraphrase, it states that energy will always be constantly dispersed. At the bottom, we have a picture. If this was a system, entropy, or the second law of thermodynamics, would simply state that the particles on this side would eventually disperse evenly until we reached a state where there were roughly the same amount of particles in both. Now, I mentioned entropy, and this is often called disorder. The second law equates to entropy. However, you need to understand that calling entropy disorder may cause you some trouble. Entropy is a measure of spontaneous dispersal of energy at a specific temperature. Yes, it does lead to a cause of more disorder, but you need to understand it's an expression of energy. Here are the 2 equations listed for entropy. Now, mathematically, entropy probably won't be tested on the MCAT, but you will be asked about what it means and what it entails. Simply put, if you notice, entropy always increases. The second equation states that the entropy of the universe would be the resulting sum of the entropy of the system and the surroundings, thus stating that everything has to be accounted for. There's our first law. But that is going to be greater than 0, stating that the change of entropy total will always exceed 0, or will always be increasing. What this leads to is the fact that every natural process is essentially irreversible. There are some changes that can be reversible under controlled conditions. However, nature generally operates under irreversible conditions. The last law states that the entropy of a perfect crystal at absolute zero is exactly equal to zero. Or, better put, it states that the entropy of a perfect crystal will approach zero as its temperature approaches absolute zero. Recall that absolute zero refers to a state where there is zero energy, period. Zero kinetic energy, that is. This is theoretical and in all likelihood impossible, but it is a concept to understand no less. This isn't directly tested on the MCAT, so we're not going to go into too much detail about it. But note that the third law is stating and extrapolating off the first two. So that's a rough overview of the thermodynamics unit and how it pertains to the MCAT. Please join us in the next lecture as we continue through our physics module.